Hello, everybody. On my way from Tunis to Savannah, I got to know that Tunisia got awarded the Nobel Peace Prize, which made me very, very proud. And I'm here today, standing on this stage, trying to keep the momentum of good news and trying to win the Ocean Award. So, energy sector is the backbone of the global economy. However, it still faces serious challenges. There's a booming demand for energy. There's a climate change issue that we have to address. There is energy security that is a main concern. So all these issues have to be addressed properly. This is the future, our future and the future of the next generation which is at stake. So the difficult equation is how to power the world while preserving nature. This is a very, very tricky question. We need to address it. And sustainable solution, renewable energy could be a very, very sustainable solution. So wind energy is one of these renewable energy that the world is counting on to provide a long-term solution. However, wind energy is still based on a technology that is quite old and has some limitation. When we talk about wind turbine, there is some question about the efficiency, about the cost, about the eco impact. Is it bird friendly or not? Is it noisy or not? Does it disturb airwave, radars, the visual integration? So all these questions are still there, and they are somehow preventing the solution to be an effective one on the long run. In terms of efficiency, these turbines are subject to aerodynamic laws called Betz limit, according to which only 59% of the initial wind kinetic energy could be captured and then converted into electricity. So factoring in any other losses, today's efficiency of the wind turbine is about 30 to 35% only. That means that up to 70% of the initial wind energy is simply lost, unacceptable. We believe that the current box that for wind turbine is the use of blades and the rotation of blades. And over the last decades, all the research, all the innovation, were within this box, trying to improve the efficiency, to lower cost, to go for scalability horizontally and vertically. But if we believe that we need to address this climate change, we need a radical solution that are economically viable. So I invite you to get away from this box and try to think differently and to get inspired from a different concept, which is a sailboat. And I'm sure many of you have been sailing or kite surfing for a while. So far, sailboat is the only mechanism capable of capturing and converting the majority of the wind kinetic energy into mechanical energy for transportation purpose. So the question here that my partner, the inventor, Anis Hawini, asked, can we use the same concept to create electricity? We come up with this new design called the Saphonian. As you can see, it is bladeless, rotationless, and is mainly inspired from sailboat. And I'm going to show you an illustration how this works. So this is a third-generation prototype that we built and tested on the rooftop of our office, in Tunisia. So this is a radical new technology. There is no blade, it doesn't rotate, and we are moving from a plan from a 2-dimension to a 3-dimension. So the motion, this back and forth motion of this body that harnessing the wind, and it's literally swallowing the wind, because it is a curved body that captures 2 times more wind that conventional turbine. So we're moving from 2D to 3D, and this is not a turbine, so it is not subject to the same aerodynamics, including the Betz limit. So if you see the shape, and if you see the wind, attacking the Saphonian, the captured kinetic energy, the upfront wind is at least 2 times, that of the wind turbine. So the Saphonian is an eco-friendly solution. It is bird-friendly because there is a compact body, and the birds, can visualize it. They don't try to pass through, so there is no limited accident in that. It's less noisy, no radar interface, because there is no blades and there is no rotation. So it's a completely new paradigm. Here, an interesting concept of biomimicry. The inspiration, when you simulate this motion of the Saphonian, the back and forth 3D, it's like a big 8 in 3D. And this motion has been observed in nature and is very, very present in nature. So, and sometimes we don't pay attention to that. For instance, for birds, when they fly, we think that they fly like that. But it's more complicated. The motion is like that. So when you simulate it, it's the big 8 in 3D. For fish, the same thing, the fish tail. It's not like that. It's like that. It's more complicated. So when you do this simulation, it's a big 8 in 3D. So here we are trying to get inspired from nature to better satisfy nature. In terms of application, there is many applications that the Saphonian could be used. I mean, obviously to generate power and to build farms, Saphonian farms. You can even repower the existing farms by just removing the blades and replacing them by the curved body with the kinematics, which is the key, because it allows this back and forth motion, because many people initially were skeptical when the wind blows, how the body will get this back and forth. And this is the key is in the kinematics. It allows this back and forth and rotation and then creation of the electricity. In terms of applications, the on-grid solution as a Saphonian could be a very interesting on-grid solution. It could be used in urban areas because it is less sensitive to turbulent winds. And this is a key because today we don't use turbine as many as we wish to do because of this turbulence. The Saphonian, tomorrow it could be equipped, let's say, a high-rise building, could be a lot of Saphonian, and it works fine. You cannot put turbine because when the wind goes through the turbine, hit the wall, then come back, and then stop the turbine. For the Saphonian, it's a different concept, so it could work fine and create green energy and reduce the stress on the structure of the tower. And you can even use it as a billboard because it's literally stable, so you can visualize, you can put Coca-Cola logo or whatever, so you can use it as billboard. You can use it as off-grid solution as well. You know, in the world there is 1.3 billion people have no access to electricity because of the problem of grid. Out of them, 400 million in India and up to 500 million in Africa. So this is a real problem. And with this off-grid solution, we can address some of it. It's a cross-cultural solution. It could be adapted to any local environment. You can even use the material, locally. It is very easy to fix and to maintain because here we are looking for the drag force of the wind. So if, let's say, Sethonium breaks, it's easy to fix. You can even screw your shirt if it's a fabric, and it works. For the current turbine, made of fiberglass, fiber carbon, it's very difficult. When it's broken, you have to order a new one from where it's expensive and could take some time to to be shipped. The team behind it, the main guy is my partner, Enis Awini, who is the inventor, a real genius. It's an old friend, 20 years of friendship. So we quit everything. He quit his job. I quit my job. I used to be a banker. And we dedicate ourselves over the last 5 years to this venture. We are progressing, and hopefully we're going to make it happen. Our board of advisors, made of some prominent name that helping us a lot financially and with their advice. 9 months ago, we signed a strategic partnership with Microsoft Corporation through their For Africa initiative to help African innovation to be brought to the world. So they are supporting us in many ways to scale our machine and to move from the R&D to the next level. The current project in progress, we are building a 1 kilowatt machine. So we are taking the prototype from the lab scale to an industrial design machine. So it is under progress, and hopefully next month we're going to do the first public demonstration to disclose the technology to the world, because so far we've been a bit reluctant, till we finalize all the intellectual property, all the other stuff. So we've been very, cautious for that. But next month, hopefully, everything will be publicized. It is a smart device. This is optional. You can build on the Saphonian because mainly it is a mechanical innovation. But here we can, and for the 1 kilowatt that we're building, we're making it a smart device with a lot of capture and sensor, which is a message to say that we are scaling our technology and we are coming to larger scale soon. We also developed our own application called Maria application for monitoring and real-time monitoring for the Saphonian. So the next step would be scalability. We are not entering the B2C, the small Saphonian market for now. We decided to go into scalability. So now we are finalizing the 1 kilowatt. The next project is 20 kilowatt, and then so on. We've signed also a memorandum of understanding with a major Indian player to set up the first pilot wind farm of 1 megawatt, which is under discussion in India. So if we'll be lucky to win the Ocean Exchange Award, we will dedicate the fund to build our first microgrid project in Tunisia, because the grid is under the national monopoly of the state. We cannot use it, we cannot inject electricity there. So we have to build our microgrid to inject the electricity and do all the testing and show the economics of the technology. Just wanted to put things into perspective. Venturing in the R&D in Tunisia is not that easy, especially post-revolution area. There is no government support, no grant. The infrastructure in Tunisia is not, we don't have this tradition for innovation. We have to rely on ourselves. We have to push things. We have also to show there is a possibility and create a precedent for young people in Tunisia and in Africa to say that we can innovate. Because all of you know that innovation, the overwhelming statistics, innovation came from places that are least expected. The garage, you name it, Microsoft, Facebook. So the garage are available all over the world. The problem is not to innovate, but how to take this innovation to the next level. And this is why your support will be really pivotal for us. Here you go. So I'm so grateful to be here. And our mission, our dream, again, is to contribute to the global effort to make this world a greener place for us and for the next generation. Thank you very much.
Thank you. You got a question?
Brilliant.
Thank you.
Can you talk about any analysis that you've done on the bearing shaft for these in terms of life cycle? Because you're putting a high torque system on a shaft, and as this thing rotates around, that is a very high wear situation. What have you done to optimize that for life? And then the second part is, how does the projected scaled installed cost relate to other technologies?
Thank you for the question. So in terms of calculation, we are using very sophisticated here software, SolidWorks, FlowWorks to calculate all this torque and all these things, and the tests are there, and the output of this simulation are there. That the system and the kinematic behind this is the first time that is being used in mechanics. The way that it allows this back and forth and create a rotation behind to attack a generator and to have electricity. So it is very smooth transmission and conversion of the mechanical energy into rotation and then into electricity. So to be honest, I'm not an engineer, I'm not an inventor to talk about something very specific. This is Anis, who can address this. But I can tell you that the tests are there, and the prototypes, we built 5 generations of prototype, and each time we improve each version to reach this 1 kilowatt industrial design that we are doing a partnership with Microsoft to show that in terms of efficiency, it is way more efficient. With regards to the economics, of course, here, what we are not reinventing the wheel. We are just changing the way the wind is being harnessed. So we are replacing the blades by this shaped body. For the materials, you can use a very cheap material, because what we need is the drag and not the lift. So here you can use sail, you can use fabric, you can use, let's say in Africa, you can use even banana trees, to put there, so that as long as you have the drag and it gets converted into electricity, you get your solution working fine.
All right. First over here.
So I have an obvious input question and an obvious output question. The input question is with regard to wind, it's an intermittent power source. So the question is, do you have a way of smoothing the flow any differently than wind turbines do now? And the output question has to do with storage and recovery, which has been a kind of drag on the system with regard to wind technology. Does your technology do anything to change storage and recovery?
Thank you very much. Indeed, storage is a very important factor here. For the Saphonian, we had 2 transmission mechanisms, either a direct one, so it's all mechanics, and you have the shaft rotating connected to the generation, you have electricity, or you can use a piston behind connected to the hydraulic motor. So you can create this pressure, and then the motor will get spinned and have the electricity. Once the pressure is created, if you want to store it, you can store this pressure in a hydraulic accumulator or any other hydraulic solution. So there is this link in between when you add the hydraulic piston and motor, where you can use when you can store your energy as a pressure. And then when there is no wind, you can get the pressure way off the hydraulic accumulator, get it in a hydraulic motor, and get your electricity.
Over here. No, you're next.
Yeah, first of all, congratulations, a great innovation. I am concerned about how sensitive Saphon is to change in wind directions, and what is the maximum amount of wind velocity it can handle. It will depend on material, I understand, but can you talk more about that?
Yeah, thank you for that. For the cut-in wind speed, we are almost the same. Don't want that we are better, but the starting wind, it's not that important, because you know that the electricity generated is a cubic function of the wind speed. So you are interested more by the higher wind speed. For that, we can go even further. For the mechanical transmission, it's very robust, and for the hydraulic transmission, is like these pistons are being like, how you call that? The transmission is instant, and I don't find it in English because, sorry, I'm French or Arabic speaking, but they can reduce the shock, and you can survive a much higher wind speed, and this is where you can convert even much electricity. So the concept itself, it's like when you are sailing, and you have a sailboat. So the fact that this sail, I mean, first of all, as you rightly said, the material and the material resistance, it is important to get that. But for the sail, it's not a blocking, it's not an obstacle, it goes with it. So like the Saphonian, it's not blocking like the turbine, it goes like that. So it's back and forth, so it allows more convention and more resistance, with a higher wind.
And change in wind direction?
The same, because either for small Saphonian you have a tail that's following, or as I mentioned, as a smart device, we have a yaw system integrated in that with a sensor, exactly, it's real-time correction, so if the direction is changing, immediately the yaw system is changing accordingly.
Thank you.
Thank you very much.
Alan.
Hi, it's a fascinating presentation. Thank you so much. I had the exact opposite question, actually. You can sail a boat in 3 knots of wind. So does your technology work at lower wind speeds? Can you cut in at a lower meters per second than a traditional turbine?
So far, yeah. We are reaching the same cut-in wind speed.
So,
we hope that probably with new materials, with more sophisticated materials, probably we can get even lower.
okay. And then do you have any estimate of the size of the units at utility scale? Like once you scale up to, say, 3 megawatt unit, what the dimensions it might be? Any estimate?
We are going, step by step now. Sure. 1 kilowatt, we are going to 20 kilowatt, and hopefully then to 200 megawatt. But what I can say is, as the system is at least twice as efficient as the wind turbine, so either for apple to apple, for the same power, you can have a Saphonian which is half a size of wind turbine, or get the same with a double of power. So, yeah, these things could, as long as in terms of efficiency, we have now the result, the calculation, and it's proving, because sometimes there is some common sense in the way that it's 3D and it captures, more wind, and then even, of course, there is losses like the wind turbine, but the output, and you compare it, with the wind turbine, is twice as efficient as a wind turbine.
I would expect it to be larger. So
we'll try to be conservative, because otherwise people won't believe us. Thank you.
Here in the center.
In a sense, you answered my question. Before I ask you, you said that 35–40% the current wind technology achieves efficiency-wise. So you said as twice. So you're going to achieve, or you already achieved that twice? And so you expect with the size, and so with the scale up, you're going to expect
Absolutely.
higher?
Absolutely. Thank you. So yeah, we achieved. Because when you for the prototype that we built, each one, the fifth one, the last one, it is there. It is. That's why sometimes we don't want to go too much and say the real stuff, but we limit to twice as efficient. But apple to apple, we are more than twice as efficient. But people sometimes think that, especially for this new innovation, I talk and they are so excited about this, but realistically, we are 2 times more efficient. And we hope now, because it's a new highway, and the R&D is there, and there is a room of improvement, a huge room of improvement, and we are working on that. We cannot work by ourselves, by our current resources. So we need, more people to get involved. In terms of scalability, yeah, we are going to the scale. That's why we decided not to go for the small, to the business yet. It's too early. And, when you go for small machine right now, it requires a lot of logistics, a lot of resources, and it's also sometimes risky, because even if we are protected, you never know who's gonna build the same at 100, copies. And so we are focusing on scalability, scale each machine up from 1, 20, 100, and each time we'll try to improve it further and even go beyond the 2 times that I've been talking about.
One over here.
Hi. You talked about off-the-grid. Is this for like single-family homes, or would you be creating a small grid within a community that would be powered by this?
Both, applies, because you can use it for a small family, to power a house, to power a boat, to pump water, for oil, platform offshore. So you can use, which is now the same for turbines. They are being used, but here, if you have a much higher efficiency and lower cost, and let's say integration for your boat, it is not noisy because there is no blades that doesn't cut the wind the way turbines are doing. So it's more silent, and you can even enjoy a visual integration. For small one, you can put a flag, you can put your picture, you can put anything, So it could be more adapted to the environment and to the application that you're going to use. Thank you.
Hazin, thank you very much.
You.
It was great.
Thank you very much.